Hi, I apologize for being interrupted and quitting so abruptly before. Okay, I just want to point out on this slide that when you have constant velocity, a graph of velocity versus time is a horizontal line, as you can see right here. And the slope of a horizontal line is 0 because there's 0 rise over the run. And if you look at the motion map, you can see for equal time intervals, the car always covers the same distance and the velocity is constant. Now, acceleration is the change in velocity divided by the time, which means it's also the slope of the velocity time graph. So if the velocity time graph is not a horizontal line, but is rather a diagonal line, hopefully you recall that lines have a constant slope, so it's going to have a constant slope, but this time it's going uphill as you go from left to right, so it's going to be a constant positive slope. And if you look at the rise over the run for the whole trip, it would be 50 meters per second minus 0, that's the rise. I keep doing that, sorry. Divided by 5 seconds minus 0 seconds, which would be 5 seconds, and 50 meters per second divided by 5 seconds is going to give you 10 meters per second, or a 10 meter per second squared slope. You'll notice when you have constant positive acceleration and positive velocity that the cars get farther and farther apart as you go farther in time. So there's that one. Okay, now I'm not going to spend a long time talking about any one of these, but I want you to, you can rewind and you can pause and you can take some notes on these. One of the things that you want to try to visualize here or connect is the position time graph, the velocity time graph, and the acceleration time graph for each of these following motions that I'm going to show you. Okay, constant positive velocity, that the graph of position versus time is always going to be a diagonal line with a positive slope. And the velocity time graph will always be a horizontal line that's above 0. It'll be positive, at a positive value. The acceleration versus time graph is a horizontal line at 0 because there's 0 acceleration. Constant negative velocity looks like this. That means it's just going in the opposite direction, and it's a diagonal line, so constant slope, but it has a negative slope. And so the velocity time graph is horizontal and is negative in the negative region of the graph. And then of course the acceleration versus time graph is still 0 because it's constant velocity. So here's a clicker question. If we were in class, I would have you do this and then discuss it with each other. Is it possible for an object's velocity to be 0 and for its acceleration to be non-zero? This is not the same question that I asked on the checkpoint. Here I want 0 velocity and acceleration to be non-zero. And in class I would have you answer it, then talk to each other, and then answer it again. And I'm saying yes, and you might be kind of confused by that, but here's the trick. I did not say constant and 0. I just said, is it possible for it to be 0? And what that means is, for 1 instant, it can be 0. So what happens is, if you throw a ball up into the air, at the top of it keeps slowing down, slowing down, slowing down because it has negative acceleration, and then at the top of its path, its velocity is 0 for an instant, and then it starts to fall back down again. So if you're just looking at an instant, then yes, velocity can be 0 and acceleration can be non-zero. Okay, so once again, acceleration and velocity are both vectors, and acceleration is a vector in the sense that it's positive or negative, and it's the rate at which an object changes its velocity. I just might mention at this point, even though I don't have a slide particularly about this at this juncture, since acceleration is a change in velocity divided by time, anytime you're changing the velocity, you're accelerating. And velocity can be changed by changing size or magnitude, so how fast can change, but also direction can change, and that's acceleration. So if you turn and start going in a different direction, you have accelerated, even if your speed stays constant. A car has 3 accelerators, actually, even though we really only call the gas pedal the accelerator. The brake is also an accelerator. It's a negative accelerator. And the steering wheel is the 3rd accelerator. So you've had a chance to be watching these cars and the graphs. Your task is to try to determine which car goes with which graph. So one of these is moving at a constant velocity, and then the other 2 are speeding up, and you need to try to match which goes with which.
Going to Joey's.
Okay, thanks.
See you later.